Hey, my name is Anurag and I'm a student in Niagara College, Canada, and this is my student ID and my student ID number is 4582210. And today's presentation topic is engineering aerothermodynamics. So in this presentation, we will learn about the background information on aerothermodynamics and two subtopics. So the first subtopic is hypersonic shock layer phenomena, and the second one is thermal protection system. And we will also learn about the scientific advancement and the beneficial global impact and detrimental global impact of aerothermodynamics. Background information on aerothermodynamics. So aerothermodynamics study how air behave at very high speed, near or above the speed of sound, and how that super fast air heats up or even changes chemically when it's squeezed and it trenches. It began it began with the research on supersonic planes in World War II, and then later became a crucial then later became a crucial part for getting a spacecraft safely back through our atmosphere. Today's engineers rely on aerothermodynamics to design fast jet, rocket, and hypersonic vehicles, and also they rely on aerothermodynamics to make a material that can survive those extreme temperature is what keeping our machine intact and flying safely. Hypersonic shock layer phenomena, the first subtopic. Imagining traveling through the sky at what is known hypersonic speed, which is more than 5 times the speed of sound. Due to its, the shock waves form ahead of craft, heating the air so intensely that molecules split and create a thin, scorching layer that presses the heat against the surfaces. In that layer, it is critical to recognize the orderly flow abruptly became a turbulent, choppy, and mixed. This is because the heat absorbs quickly in turbulent layer, which can endanger your material. Engineers now utilize sophisticated programs that address the entire physics of hot, rapid gases. The second subtopic is thermal protection system. To survive in the extreme temperature during the flight and the re-entry, spacecraft use thermal protective system. So there are two primary type of thermal protection system. The first one is reusable shield, like this. Reusable shield, such as a black tiles on a space shuttle, which continue to block heat. And the second one is ablative shield, which sacrifice itself or peel away during a re-entry and carry the heat with them. Today's hypersonic rocket and re-entry vehicles have lighter, tougher shield in one package thanks to advancement in ultra-high temperature ceramic and nano-engineering ablatives. Yes. The scientific advancement PICA. So the NASA aims Research Center has developed a new technology called phenolic impregnated carbon ablator, or PICA for a short, which function as a heat sponge for a spacecraft. It is a mixture of carbon fiber and a resin. So it first it firstly proved itself on the Stardust sample return mission in 2004, and then later on Mars Science Laboratory rover. The PICA's lightweight design and dependable shielding allow mission planner to reduce bulk by kicking out kilos, ensuring the craft's survival. You can see in this image a scientist preparing PICA heat shield for a Mars re-entry capsule at NASA's laboratory. The beneficial global impact. Arthur, Aerothermodynamic has a far-reach benefit. It makes satellite possible for communication, weather forecasting, and climate monitoring, and engineer it leads to engine and turbines. It even enables planetary mission by keeping probes safe during fiery entries. Fiery entries. But but there are also a downside. Rocket burns a large amount of fuel, producing a greenhouse gases and stratospheric water vapor that can harm ozone layer. Making and disposing of a heat shield material create hard to recycle waste, and hypersonic weapon failing debris ethically, security and safety concern. So balancing these advances with green technologies and strict safety measure is key to using aerothermodynamic responsibly. You can see a, a bright exhaust cloud from a SpaceX Falcon 9 launch visible across the Southern California. Other references I used to make this presentation, and thank you and have a great day. Take care.